What if the universe we live in is just a bubble, floating among many others? This audiobook invites you to explore one of the most perplexing ideas in modern physics, that there could be infinite universes, each with its own laws, separated by a constantly expanding space. Universes that are born, grow, and drift apart, unaware of each other. A journey through a fragmented cosmos where each bubble is a distinct reality. And we are just one possibility among many. To begin with, what exactly are bubble universes? Imagine a sea of bubbles floating in an ocean of space. Each bubble represents a different universe with its own physical laws and realities. Some may be similar to ours, while others could be completely strange. This idea is not only intriguing, but also raises questions about our own existence. Are we unique or just another bubble in a vast multiverse? String theory, which suggests that fundamental particles are not points but vibrating strings in multiple dimensions, helps us understand how these bubble universes can exist. The additional dimensions proposed by this theory are like hidden pathways in the fabric of space-time. If we imagine our universe as a book in an infinite library, each bubble universe would be a different chapter, each with its own narrative. Now let's talk about cosmic inflation. This process occurs in the early moments of the universe when it expanded at an incredible speed. Imagine you are inflating a balloon. At first it seems small, but as you blow into it, it expands rapidly. Similarly, cosmic inflation allows bubble universes to form, each arising from the explosion of energy in the vacuum. But what happens after that explosion? How does one universe become independent of another? The answer lies in how these universes separate. Just like soap bubbles that form and float in the air, bubble universes can be independent, yet still share the same space. The expansion of the universe plays a crucial role in this process, creating a sea of realities that can coexist without interfering with each other. However, the idea of separate universes raises even more intriguing questions. Could they interact in some way? Theoretical physics suggests that they can. Although each bubble may seem isolated, there is a possibility that there are ways for them to interact. What if one bubble universe could influence another? Perhaps one bubble could touch another, generating effects that could be detectable in our own universe. The notion that we might have neighbors in parallel realities is both exciting and unsettling. But what scientific evidence supports the existence of these bubble universes? Astronomical discoveries, such as certain irregularities in the cosmic microwave background radiation, suggest that there are patterns that could indicate multiple universes. As scientists conduct simulations and observations, the idea of bubble universes becomes increasingly plausible. Venturing into the realm of philosophy, this notion also raises questions about information. If each bubble universe is independent, what happens to the information generated within them? Could it be lost forever in the abyss of the multiverse? Or are there ways for information to travel between bubbles? This is an intriguing dilemma that physicists are still trying to resolve. Quantum gravity adds another layer of complexity to this discussion. As scientists attempt to unify general relativity and quantum mechanics, the theory of bubble universes becomes a crucial field of study. How does gravity behave in a bubble universe? Is it the same as in ours? Or do new rules emerge? As we explore these questions, we enter a territory where time and space may have completely different meanings. Reflecting on time, an intriguing question arises. How is time perceived in bubble universes? In our universe, time seems to flow linearly, but could it be that in other universes, time is something entirely different? Perhaps in some bubbles, time does not exist or functions cyclically, challenging our most fundamental notions. As we explore these realities, it is interesting to consider alternative theories to the multiverse. There are explanations that do not require the existence of bubble universes, but each of them presents its own challenges and limitations. Science is always evolving, and it is fascinating to observe how these different theories compete and collaborate with each other. Finally, the implication of bubble universes leads us to question our own existence and the place we occupy in the cosmos. If there are other universes, what does that mean for life as we know it? Could there be forms of life in universes where the laws of physics are completely different? The search for answers to these questions is not only scientific but also deeply philosophical. In summary, the idea of bubble universes invites us to look beyond our own world and question what we know about reality. As we move forward in this exploration, let us remember that each answer may lead us to new questions, and each discovery may open the door to a deeper understanding of the vast and mysterious cosmos in which we live. String theory presents itself as one of the most fascinating and complex ideas in the realm of theoretical physics. But what exactly is string theory, and why is it so important for our understanding of the universe? When thinking about it, imagine that everything we know, from the stars in the sky to the smallest particles that make up matter, are merely different musical notes in a vast cosmic symphony. Each vibrating string represents a fundamental particle, and the melody produced by these vibrations determines the properties of matter. One of the most surprising features of string theory is its proposal of additional dimensions. While our everyday experience is limited to 3 spatial dimensions and 1 temporal dimension, this theory suggests that there are extra dimensions that we cannot perceive. How is it possible that something so fundamental goes unnoticed? The additional dimensions could be curled up in such tiny shapes that they are invisible to our senses. Think of an electrical cable. From a distance, it appears to be a one-dimensional object, but as you get closer, you can see that it has thickness, and if you look closely, it might even have complex structures on its surface. The idea of multiple universes intertwines with string theory in an intriguing way. If each string can vibrate in different ways, then each vibration could correspond to a different particle in a distinct universe. This opens the door to the possibility that many universes exist, each with its own physical laws. Can you imagine a universe where gravity is stronger, or one where time flows differently? String theory invites us to consider that our reality is just a small part of a vast multiverse. Now let's delve into how string theory connects with cosmic inflation, a phenomenon that describes the rapid expansion of the universe in its early moments. This expansion not only created the space we inhabit, but could also have generated bubbles of space-time that became independent universes. Imagine the universe as a large pot of boiling water. As it heats up, bubbles form and rise to the surface. Each bubble could be a bubble universe, separate and unique, created in an instant of expansion. As we explore string theory further, it is essential to understand how these strings interact. Each string can join and separate, creating new particles and potentially new universes. This process of creation and destruction is similar to how waves in the ocean form and fade away. The dance of strings in additional dimensions can give rise to a variety of phenomena that we do not yet fully understand. The connection between string theory and bubble universes raises intriguing questions. If there is an infinite number of universes, how many of them could be similar to ours? Could there be a universe where oxygen is toxic to life, or one where the laws of physics are completely different? Imagination runs wild when considering the infinite possibilities that could arise from this theory. However, not everything is simple. String theory, despite its elegance, faces significant challenges in its experimental validation. The additional dimensions it proposes are so small that they elude our current measurement tools. How can we test the existence of something we cannot see or touch? This raises a fascinating paradox. Can something be real if there is no direct evidence of its existence? The implications of string theory are not only scientific but also provoke deep philosophical reflections. If multiple universes exist, what does that mean for our identity and our understanding of reality? Questions about free will, life after death, and destiny are challenged by the idea that we might be just one version of ourselves in a sea of infinite possibilities. In this context, string theory also invites us to reflect on the nature of reality itself. If each bubble universe has its own physical laws, who are we in the grand scheme of the multiverse? With each discovery, we move closer to understanding that our reality is just a thread in the enormous tapestry of the cosmos. The search for evidence supporting string theory and the existence of bubble universes continues. Scientists are using simulations and experiments to explore these abstract concepts. As we advance in our understanding, we may be on the brink of discoveries that will radically change our perception of the universe. String theory is not just a field of study, but an invitation to explore the boundaries of science and philosophy. It challenges us to think beyond the known and to open our minds to the wonders of the cosmos. Science and human curiosity are intertwined, and the quest for answers to these fundamental questions is what drives us forward. In summary, string theory is a fascinating kaleidoscope of ideas that intertwine additional dimensions, multiple universes, and the nature of reality. It invites us to imagine a universe beyond what we can see and experience, and to consider that in every vibration of a string there could be the echo of a bubble universe waiting to be discovered. Cosmic inflation is a fascinating concept that helps us understand how our universe formed as we know it. But what does cosmic inflation really mean? Imagine that the universe is like a balloon. When we inflate the balloon, it expands rapidly, stretching and becoming larger. Similarly, in the first moments after the Big Bang, our universe experienced an incredibly rapid expansion known as inflation. This expansion not only made the universe grow, but also helped establish the necessary conditions for the structures we see today, such as galaxies and stars. But what does this have to do with bubble universes? It turns out that cosmic inflation did not necessarily stop after the creation of our own universe. Instead, some scientists suggest that inflation may continue in different regions of space. This creates bubbles of space-time, each of which could be a distinct universe with its own physical laws and characteristics. Thus, in a vast multiverse, we could have many bubble universes, each isolated and unique. How do these bubble universes form? Imagine an ocean where air bubbles begin to form and rise to the surface. Each bubble is a bubble universe, and each one forms from fluctuations in the inflationary field. When this field cools, it can give rise to regions where inflation stops, creating a new universe in a process that could be completely independent of the rest. It's as if in a great sea of possibilities. Each bubble emerges in isolation, with its own set of rules and characteristics. One might wonder, how do we know that this cosmic inflation and the creation of bubble universes are more than just science fiction ideas? Observational evidence has begun to support these theories. For example, variations in the cosmic microwave background radiation, a kind of echo of the Big Bang, show us patterns that could be consistent with inflation. These small fluctuations in the radiation are like ripples on the surface of a lake, revealing the history of what happened in the earliest moments of the universe. However, there is more than just the creation of bubble universes. Cosmic inflation also raises intriguing questions about the fate of our own universe. As the universe continues to expand, we might find ourselves in a scenario where our reality moves away from other bubbles, making them inaccessible. It's as if each bubble drifts away in an infinite sea and we remain trapped in our own bubble, unable to see what lies beyond. As we explore cosmic inflation more deeply, it is important to ask, what kinds of universes could exist in this vast multiverse? Some might have physical laws completely different from ours, which could allow for the existence of forms of life we cannot even imagine. The diversity of universes could be as rich as the variety of species on our own planet. What if we found a universe where gravity is weaker or where fundamental constants are different? The possibilities are truly astounding. In this context, cosmic inflation and the bubble universe theory also allow us to reflect on the nature of reality. If there are infinite universes, what does that mean for our perception of what is possible? Are we alone in our bubble? Or are there other beings in distant universes also wondering about their place in the cosmos? The philosophical questions arising from inflation theory are as profound as the scientific ones. On the other hand, we must consider the challenges posed by cosmic inflation. Despite its appeal, some scientists question the lack of direct evidence for these bubbles. If bubble universes are independent and do not interact with ours, how can we even begin to search for proof of their existence? It's an intriguing dilemma that leads us to rethink our ideas about observation and evidence in cosmology.
Meanwhile, the study of cosmic inflation remains an active field of research. New theories and models are continually emerging, each offering a new perspective on how the cosmos might work. The search for answers leads us to explore computational simulations and experiments that attempt to unravel these mysteries. Each discovery has the potential to change our understanding of the history of the universe. One of the most exciting questions arising from cosmic inflation is, what role does quantum gravity play in all this? Quantum gravity is a field that seeks to unify general relativity and quantum mechanics, and its relationship with inflation and bubble universes could be fundamental to understanding the nature of space and time. The combination of these theories could open new doors to understanding how the universe originates and how it behaves. It is natural to feel a mix of wonder and curiosity about these concepts. The idea that we could be part of an infinite multiverse is both fascinating and disconcerting. It invites us to question our own existence and reflect on our most fundamental beliefs about reality. What does it mean to be human in a universe where countless parallel realities exist? Cosmic inflation, with its ability to create bubble universes, gives us a new perspective on the cosmos. In the end, the quest for answers about our place in the universe and the possibility of other universes reminds us that human curiosity is infinite. Science not only offers us answers, but also opens the door to new questions, challenging us to continue exploring the unknown. The exploration of cosmic inflation and bubble universes is not just a journey toward understanding the cosmos, but also an invitation to dream and imagine what might lie beyond our bubble. Each discovery, each theory, and each question brings us a little closer to unveiling the mysteries of the universe. So while the search for answers may be long and complicated, each step along this path brings us closer to a deeper understanding of what it means to be part of this vast and enigmatic cosmos.
In the vast stage of the cosmos, there exists a fascinating concept that awakens curiosity: the bubble universe. What exactly is a bubble universe? To understand it, we must first imagine our own existence as a bubble in a sea of other bubbles, each representing a distinct universe. Just as bubbles can be of different sizes and colors, each bubble universe has its own characteristics and physical laws. But how do these bubbles form, and what makes them different from our universe? Bubble universes arise from a process involving cosmic inflation, a phenomenon that occurs in the early moments of the universe. During this phase, space expanded at an extremely rapid rate, similar to how a balloon inflates quickly when air is blown into it. In this context, our universe is just one of those bubbles that formed amidst this expansion. But why do some bubbles separate and become independent universes? The answer lies in the very nature of inflation. As space expands, different regions may experience variations in their energy and density. These fluctuations can give rise to bubbles that detach from the whole, forming universes that may have different properties. Imagine a river where water flows in different directions. At certain points, small currents may diverge and create independent ponds. Thus, each bubble universe becomes a unique pond in the vast ocean of the multiverse. In this context, the question that arises is, what makes a bubble universe unique? Bubble universes can differ in their physical constants, meaning that the rules governing each one can be completely distinct. There could be universes where gravity is stronger or weaker, or where elementary particles have different properties. This raises an intriguing question. If other universes existed, could we even imagine them? The comparison between our universe and a bubble universe leads us to think about infinite possibilities. What if in a bubble universe the laws of physics allowed time travel to be possible? Or what if in another universe life evolved in ways we cannot even conceive? These questions fill us with wonder and remind us that our understanding of the cosmos is just a fraction of what could exist. As we explore the idea of bubble universes, it is essential to consider how they interact with one another. Although they are separate, theory suggests there could be ways of connection between them. Imagine a network of bubbles floating in infinite space. Occasionally, one bubble might touch another, exchanging information, energy, or even matter. This leads us to wonder, what would it mean for our understanding of reality if interactions between bubble universes existed? The notion of bubble universes also invites us to reflect on time. In a bubble universe, time might flow differently. For example, in a universe where gravity is more intense, time could pass more slowly than in our own universe. This idea may seem strange, but it challenges us to think about how we perceive reality and how time can be something more than a fixed constant. Considering all these possibilities, one might wonder if there is evidence that these bubble universes actually exist. Although science is still exploring this question, there are theories and simulations that suggest they could be more than just an abstract idea. Astronomical discoveries have begun to reveal hints of phenomena that could relate to the existence of bubble universes, although definitive confirmation is still forthcoming. At its core, the exploration of bubble universes is not just about science. It also raises profound philosophical questions. If there are multiple universes, what does that mean for our identity and our place in the cosmos? The idea that we could be in one of many universes might make us feel small, but it also offers a broader perspective on existence and the diversity of life. Ultimately, the concept of bubble universes reminds us of the wonder of the universe we live in. It invites us to explore, to question, and to imagine what might lie beyond what we see. The pursuit of knowledge about these universes is not just a scientific adventure, but also a journey toward understanding ourselves and our place in the vast cosmos. Every answer we find leads us to new questions, and in that process we get a little closer to unraveling the mysteries of the bubble universe. Have you ever thought about what a universe so different from ours might be like, one that formed in a different instant and under different rules? In the vast and mysterious cosmos, the idea that multiple universes exist may seem extraordinary. But science offers us a fascinating glimpse into how these bubble universes separate from one another, creating an infinite tapestry of realities. Imagine a balloon that slowly inflates. At first, it is a smooth and uniform surface. But as it expands, it begins to form bubbles that move away from each other. This is a good starting point for understanding how bubble universes could form and separate in space. As the universe expands, there are moments when certain regions may experience conditions that allow them to birth as a bubble universe. But how does this happen exactly? When we talk about the separation of universes, it is important to consider the role that cosmic inflation plays. In this context, inflation is like a breath of air that pushes those bubbles as they form. Each bubble that is created may have completely different properties from our own universe, such as distinct physical laws or even different dimensions. What about the idea that these bubbles can coexist in the same space? The answer lies in the very nature of space-time. As it expands, space can divide into independent regions, allowing these bubbles to evolve in isolation. It's as if you have several balloons in a room, each with its own environment and characteristics. Over time, these bubbles can move apart so much that they become inaccessible to each other, meaning there is no way for them to interact or influence one another. The question that arises is, what happens to matter and energy in these bubble universes? Each of them could harbor its own stars, planets, and even forms of life, all with their own rules. This isolation not only affects the physics of each bubble, but also the possibility of life, as we know it, existing in these other universes. In a bubble universe where the laws of physics are different, life could look completely different from what we understand. Looking more closely, we must consider how the expansion of the universe affects the separation of these bubbles. The speed at which they expand can be so fast that even light cannot reach the most distant bubbles. This raises an intriguing question. If there are other universes out there, will we ever be able to see them or communicate with them? The answer seems to be a resounding no, at least with the technology and knowledge we have at this moment. However, this does not mean that the idea of bubble universes is not fascinating. In fact, it is quite the opposite. Interactions between bubble universes are a topic that sparks curiosity. Some scientists speculate that there could be forms of interaction, although these would be limited by the barriers of space and time. It could be that, under certain conditions, one bubble universe interferes with another, although this would be extremely rare and difficult to observe. How would this affect matter and energy in each universe? Imagine if one bubble could influence the growth of another, like two plants growing in a garden. Could they share resources or even information? As we consider the separation of these universes, it is important to reflect on how gravity plays a crucial role. Gravity, that force that keeps our feet on the ground, could also be a determining factor in how these bubbles develop and evolve. If one bubble has stronger gravity, it could attract matter from its surroundings, while another bubble with weaker gravity might not be able to do so. This leads us to think about the diversity of realities that could exist and the interactions that could give rise to new dynamics. In this context, it is essential to ask about the nature of time in these bubble universes. If each bubble has its own time and space, then how does time manifest in each of them? It may be that in one bubble universe, time passes more quickly or more slowly than in ours. This introduces a fascinating complexity in how we understand not only our universe but also the perception of time in general. The separation of bubble universes leads us to explore the idea that, although they could be completely different, they might also share fundamental similarities. Perhaps there are universal laws that govern all universes, and in that case, what implications would this have for our understanding of physics? If one day we could find a connection between these universes, it would mean that our understanding of reality is much broader than we have imagined. The question of the existence of bubble universes is not just a scientific issue. It is also a philosophical one. What does it mean to be part of a universe in a sea of other universes? If we are just one bubble in a vast ocean of realities, what role do we play in the cosmos? The idea that other universes exist may make us feel small, but it also offers us an astonishing perspective on our existence. Finally, the separation of bubble universes invites us to continue exploring the cosmos. Each discovery and each new theory brings us a little closer to understanding the complexity of the universe. As we advance in research, the possibility that multiple universes exist becomes a beacon of curiosity and inspiration. Who knows what else we might discover on this journey through space and time? Have you ever thought about the possibility that beyond our universe there are other universes developing in parallel to ours? This idea, although it sounds like science fiction, has been a topic of debate among theoretical physicists for decades. The existence of parallel universes, also known as bubble universes, not only challenges our understanding of the cosmos, but also raises fascinating questions about the nature of reality itself. In the realm of theoretical physics, the notion of parallel universes is related to concepts that, at first glance, may seem strange. Quantum theory, for example, suggests that particles do not have a defined state until they are measured. This means that, at a fundamental level, reality could split into multiple possible outcomes. But what if those splits not only existed at the quantum level, but also manifested on larger scales, creating entire universes that coexist alongside ours? One of the pillars supporting the idea of parallel universes is cosmic inflation. This theory proposes that, in the early moments after the Big Bang, the universe expanded at an incredible rate. What if, in that process, some regions of space separated and evolved independently, forming bubbles that became distinct universes? This phenomenon is not just a play on words, it is a way of thinking about how the structure of the cosmos could be much more complex than we imagine. In physics, some models suggest that every time a decision is made or a measurement is taken, a new universe could be created. Imagine a tree with branches. Each choice we make could represent a fork in the trunk of that tree, leading to new branches. Thus, each of our decisions could be creating a different universe where our lives take alternative paths. This concept is known as the many worlds interpretation, and although it may seem like a far-fetched idea, it is one of the ways physicists attempt to make sense of quantum reality. But what are the implications of having parallel universes? If they truly exist, they could offer answers to some of humanity's deepest questions. For example, is there life in those other universes? Are there versions of ourselves that have made different choices? These questions are not only intriguing from a scientific standpoint, but also invite reflection on identity and free will. Bubble universes also open the door to the possibility that the laws of physics are not universal. In each bubble, the constants and fundamental forces could vary. Imagine a universe where gravity is stronger or where the speed of light is different. These variations could lead to completely distinct realities where life as we know it would be impossible. Another intriguing question is how these universes interact. Is it possible that there is some form of communication between them? Some theorists suggest that there could be subtle effects manifesting in our universe as a result of the influence of other universes. However, so far the evidence for such interactions remains purely speculative and subject to debate. In the context of physics, the existence of parallel universes also challenges the notion of what we consider real. If there are infinite versions of our universe, each with its own history and laws, how do we define reality? This is a question that has fascinated philosophers and scientists alike and continues to be a topic of discussion. In the field of cosmology, the search for evidence supporting the existence of these bubble universes is a growing area of research. Physicists are exploring the possibility of detecting traces of other bubbles in the cosmic microwave background, a kind of echo of the Big Bang. As technology advances, future observations could shed light on the existence or absence of parallel universes. However, not everyone is convinced that these universes exist. Some criticisms focus on the lack of empirical evidence supporting the bubble universe theory. Being an idea based on highly abstract and speculative concepts, many scientists remain skeptical about the possibility of ever proving the existence of these parallel worlds. As research in this field progresses, new theories are emerging that attempt to explain the creation of universes in different ways. Some propose that the multiverse could be a consequence of particle physics, while others suggest that universes could arise from specific initial conditions. Each of these theories offers a unique perspective on the nature of the cosmos. In a way, the idea of bubble universes invites us to expand our understanding of the universe and ourselves. It challenges us to question our perceptions of reality and consider that what we see and experience may be just a small part of a much larger picture. Ultimately, the exploration of these concepts is not just a journey towards scientific knowledge, but also an exploration of the nature of existence itself. The discussion of parallel universes is not just a matter of physics, it also has profound philosophical implications. It leads us to reflect on our own existence, our choices, and the meaning of life. As we advance in our understanding of the cosmos, we may discover that bubble universes are more than just a scientific curiosity. They are an invitation to contemplate the mystery of reality in its purest form. Is it possible that interactions exist between bubble universes? This fascinating question leads us to explore how different universes might influence each other, despite being separated in dimensions that we can barely conceive. Imagine a vast ocean where each bubble is a universe, floating freely but not completely isolated. What would happen if, under certain circumstances, these bubbles could touch or even merge? Let's consider an event that could occur in this cosmic ocean. Suppose a particular bubble expands so rapidly that its surface brushes against another nearby bubble. At first glance, it seems that these bubbles have nothing in common. However, in that fleeting moment, they could exchange information. What kind of information could travel between them? It could be energy, particles, or even fundamental concepts that might alter the reality of each universe. This leads us to pose another question. What would happen if the laws of physics are not completely independent in each bubble? If in one universe the physical constants are slightly different, could that somehow affect a neighboring universe? Imagine a universe where gravity is stronger. If a bubble of this kind collides or connects with another bubble, it could generate unexpected phenomena such as the creation of wormholes or energy transitions. In this context, it is interesting to consider the concept of celestial bodies in these universes. Could a planet in a bubble universe have a gravitational effect on a planet from another universe? Although the idea seems pulled from a science fiction novel, theoretical physicists have begun to investigate how interactions might manifest and what implications they would have for our understanding of the cosmos. An intriguing example of these interactions is the phenomenon of background radiation. This is the echo of the Big Bang that can still be observed in our universe, but what if, at a moment of collision between bubbles, energy were generated that filtered into our universe as a kind of echo from another? The possibilities are as exciting as they are enigmatic. Now, is it possible that the bubbles communicate in a more subtle way? Some theories suggest that certain quantum events could allow information to cross the boundary between universes. This could be comparable to a conversation through a door between two rooms. While the rooms represent independent bubble universes, the door could be a quantum phenomenon that allows the exchange of ideas or energy. However, not everything is that simple. If these interactions are possible, what would their consequences be? Imagine that a small change in one bubble universe triggers a domino effect in another. The alterations could range from the formation of new galactic structures to the emergence of completely different life forms. Each interaction could be a spark that ignites a fire of cosmic creativity. The question that arises then is, could we ever observe these interactions? The answer is uncertain, but scientists continue to search for signs of such events. Technology is advancing, and with it, our ability to observe phenomena that once seemed impossible. Perhaps one day, astronomers will manage to capture the signal of a bubble that has touched another, thus revealing a message from a distant universe. It is important to mention that although these ideas are fascinating, there is also a component of skepticism in the scientific community. Many researchers argue that the lack of tangible evidence for these interactions makes them difficult to accept. However, science is in constant evolution, and what seems impossible today could become a reality tomorrow. The relationship between bubble universes is a field of study that challenges our perceptions and leads us to rethink what we know about the cosmos. It invites us to consider how what happens in one universe could have repercussions in others, leading to an interconnected web of realities. Ultimately, exploring these interactions not only expands our understanding of physics, but also reminds us of how little we know about the universe we live in. Each discovery brings us closer to unraveling the mysteries of the cosmos, and each open question is an invitation to keep exploring. What other surprises await us in this vast sea of bubbles? The answer to that question may define our existence and our place in the universe. The existence of bubble universes has captured the imagination of scientists and enthusiasts alike. But what kind of evidence do we have to support this fascinating idea? To understand it, it is essential to dive into the vast ocean of the cosmos and observe how science has begun to glimpse what might lie beyond our observable universe. Astronomers have made astonishing discoveries in the last century. For example, the cosmic microwave background radiation, an echo of the Big Bang, provides us with clues about the early moments of our universe. This radiation is like an ancient echo that speaks to us of a time when everything was concentrated in a single point. But what if that same radiation could also give us hints about other universes? Some scientists believe that certain variations in this radiation could be traces left by the collision of our universe with other bubbles. The observation of the structures of the universe also plays a crucial role. When we look up at the sky, we see a vast web of galaxies that appear to be distributed uniformly. However, this distribution is not perfect. There are voids and clusters, and some researchers suggest that these irregularities could be a consequence of the expansion of multiple universes. Thus, by studying how galaxies cluster, we might be indirectly looking at the scars of bubble collisions in space-time. Computer simulations have revolutionized our understanding of the cosmos. Scientists create models that simulate the formation and expansion of universes, and some of these models suggest that it is possible for other universes with different physical laws to exist. It's as if we have a virtual laboratory where we test the rules of the cosmic game. What if one day we could find a way to connect with those universes? Gravitational waves, those disturbances in space-time, are another piece of the puzzle. When two black holes collide, they generate waves that travel through the cosmos. Some theorists have proposed that if a bubble universe collides with ours, we might detect those waves as a form of evidence. Could it be that the universe is sending us subtle signals from its neighbors? The search for exoplanets also offers clues about the existence of bubble universes. By studying planets in other star systems, scientists begin to understand the variations in conditions that allow for life. If we find worlds with characteristics that challenge our expectations, it could indicate that there are universes with different physical laws. What does this mean for the possibility of life elsewhere? The patterns of the universe's expansion are also intriguing. By observing how galaxies move away from each other, researchers have noticed that the speed of this expansion is not constant. This phenomenon could be an indication that we are in a bubble universe interacting with others. The bubbles may be in constant motion, affecting how the space we know expands. Theories about dark matter and dark energy are also intertwined with the idea of bubble universes. These mysterious forces make up most of our universe and are fundamental to understanding its structure. Some scientists suggest that dark matter could be a manifestation of interactions between different universes. Could it be that what we consider empty space is filled with life from parallel universes? Cosmology has also benefited from advances in particle physics, in experiments like those conducted at the Large Hadron Collider. Scientists attempt to unravel the fundamental properties of matter. Some of the results have led to theories suggesting the existence of additional dimensions, which could be gateways to other universes. Are we one step away from discovering that our reality is just a small part of a much larger whole? The study of black holes also offers fascinating clues. It has been theorized that by entering a black hole we could be transported to another universe. This raises intriguing questions about the nature of information and physics itself. What happens to all the information that falls into a black hole in a bubble universe? Could that be a way to travel between universes? Thought experiments are also valuable tools in this research. By imagining hypothetical scenarios, scientists can explore the implications of the existence of bubble universes. For instance, if one bubble universe separates from another, could different versions of ourselves exist in those universes? How would our decisions play out in a multiverse? Astronomical observations continue to shed light on these questions. Increasingly powerful telescopes allow us to look further back in time and space. Each new image of the cosmos is an opportunity to discover something surprising. What secrets lie in the darkness of the universe that we have yet to unravel? The search for bubble universes is not just a matter of science. It is also a journey toward understanding our own existence. Each discovery brings us a little closer to answering fundamental questions about who we are and where we come from. How many realities might be waiting to be discovered? Scientists continue to explore these ideas, and although we have not yet found definitive proof of bubble universes, the path of research is exciting. Science is advancing by leaps and bounds, and each finding gives us a new perspective on our place in the cosmos. Are we ready to accept that our universe might be just one of many? As we reflect on the evidence supporting the existence of bubble universes, we realize that each discovery invites us to imagine a cosmos filled with infinite possibilities. Human curiosity is insatiable, and each answer generates new questions. Thus, the journey toward understanding the universe becomes an endless adventure where each day could reveal something extraordinary. In the vast universe of theoretical physics, a fascinating dilemma arises. What happens to information when it exists between bubble universes? To address this intriguing question, it is essential to understand what information means in the context of physics and how its handling can vary across different universes. Information, in simple terms, is any data that can be stored, communicated, or processed. But what happens when that information is trapped in a bubble universe separated from other universes? Let's consider the image of a gigantic library. Each book in that library represents information. In our universe, we can read, share, and learn from those books. However, what happens if a group of books is in a bubble that cannot interact with the rest of the library? Could we access that information? This is the heart of the information paradox. When a bubble universe forms, it seems to create an independent space where the rules of physics may differ from those we know. In this context, the question that arises is the information that exists in a bubble universe lost forever, or can it somehow be recovered? To understand this, it is valuable to explore the notion that information is never lost, a principle that many physicists uphold. Imagine that the information in a bubble universe is like a radio signal emitted from a station. If you have a receiver within that universe, you can pick up the signal and understand the message. But if you are outside that universe, the signal becomes inaudible. This situation poses a dilemma. Could there be ways to design receivers that allow us to capture information from other bubble universes? We do not have the answers yet, but the possibility suggests that the quest for information is more than an abstract concept. It is an active exploration of the cosmos. The paradox intensifies when we consider black holes. According to the theory of relativity, when something falls into a black hole, it seems that information is lost. However, some scientists propose that this information could be encoded on the surface of the black hole, known as the event horizon. This leads to a dilemma. Could something similar occur between bubble universes? Could the information from a bubble universe be encoded in some way on the boundary that separates it from other universes? Moreover, the idea that information can be preserved raises questions about the very nature of reality. If each bubble universe is a unique space with its own history, does this mean that each one has its own version of information? Is it possible that the same information is repeated in different universes with subtle variations? This thought may seem strange, but it opens the door to a fascinating field of study. The concept of quantum entanglement also plays a crucial role in this discussion. In quantum mechanics, particles can be entangled in such a way that the state of one particle instantaneously affects the state of another, regardless of the distance separating them. Could quantum entanglement be a bridge between bubble universes, allowing information to flow between them? This idea, although still speculative, invites us to imagine new possibilities for how information might travel through the multiverse. However, the notion that information could cross between universes poses conceptual challenges. What would happen if the information from one bubble universe influenced the structure of another? The implications would be enormous. We could be talking about an interconnected network of universes where decisions and events in one could have repercussions in another. This resembles a science fiction plot, but theoretical physics leads us to explore such narratives. The question of information is not only scientific but also philosophical. If we consider that information is essential for constructing reality, what does this mean for our own existence? Could it be that our understanding of life and the universe is limited by the information we have access to? Reflecting on this may change our perspective on knowledge and the pursuit of truth. Meanwhile, researchers continue to seek answers to these questions. Through mathematical models, simulations, and experiments, scientists are trying to unravel the mysteries of information in the context of bubble universes. Each discovery could provide another piece to the puzzle of reality and help us understand how we fit into this vast multiverse. Ultimately, the information paradox between bubble universes is not just a riddle of physics, it is a reminder of how little we know about the nature of the cosmos. The deeper we delve into these questions, the more we realize that the universe is a place full of surprises and mysteries. The quest for answers takes us on a journey that, while challenging, is also profoundly rewarding. Thus, when considering the information paradox in the context of bubble universes, we face a sea of questions that remain unanswered. Each inquiry is an invitation to explore, to investigate, and to expand our understanding of reality. In this journey, every step we take brings us a little closer to unraveling the secrets of the cosmos and perhaps to understanding our own existence in this vast and enigmatic multiverse. Quantum gravity is one of the most intriguing topics in modern physics. What if I told you that this theory could offer us a new perspective on bubble universes? To understand this relationship, we must first consider what quantum gravity is. This theory attempts to unite quantum mechanics, which describes the world of the very small, with general relativity, which deals with gravity on enormous scales. Quantum gravity seeks to understand how gravity and space-time function in the context of subatomic particles. In this fascinating field, many questions arise. Could it be that quantum gravity helps us understand why bubble universes exist? To answer this, let's think about how gravity behaves on quantum scales. In our universe, gravity is the force that keeps planets in orbit and makes us fall to the ground. But in the quantum world, things are much stranger and less intuitive. Imagine that in a bubble universe, gravity could behave differently. Perhaps in other universes, gravity does not act as we know it. Have you ever wondered what a universe would be like where gravity allowed particles to behave in ways that would be impossible in our universe? This idea leads us to think that quantum gravity could be the key to unlocking the secrets of bubble universes. An interesting concept that arises from quantum gravity is the idea that space and time are not fixed entities, but rather malleable. In a bubble universe, space-time could be so flexible that each bubble may have its own structure. This opens the door to the possibility that universes with different physical properties coexist in the same multiverse. What implications would this have for our understanding of reality? When we consider the formation of bubble universes, quantum gravity becomes a crucial player. During the process of cosmic inflation, where the universe expanded rapidly, quantum gravity might have played a role in the fragmentation of space. In this sense, bubble universes may be the result of quantum fluctuations that, upon expanding, create independent bubbles of space-time. Could it be that each bubble has its own history and evolution, governed by its own physical laws? The connection between quantum gravity and bubble universes also leads us to reflect on the nature of information. In physics, information is fundamental, and the information paradox is a hot topic. What happens to information when one bubble universe separates from another? Is it lost, transformed, or simply moved to another part of the multiverse? These questions challenge us to reconsider what we understand about the conservation of information and its role in the structure of the cosmos. Moreover, we must consider the challenges that quantum gravity faces in trying to explain the behavior of bubble universes. The current theory has yet to reach a consensus on how to effectively combine general relativity and quantum mechanics. This means that there is still much to discover. What new theories could emerge from this intersection between quantum gravity and bubble universes? The search for a unified theory could lead us to surprising discoveries. Perhaps in the future, we will be able to observe or even interact with other universes. Can you imagine a world where science can demonstrate the existence of bubble universes? It would be a revolution in our understanding of the cosmos and our place within it. In the meantime, quantum gravity and bubble universes show us that our understanding of the universe is still very limited. There are so many unanswered questions and so many possibilities to explore. Science continuously advances, and what seems impossible today could be part of our reality tomorrow. Are you ready to keep exploring these mysteries of the cosmos? The implications of quantum gravity in bubble universes are not only fascinating from a scientific perspective, but also invite us to reflect on our existence. If there are other universes, each with its own rules and realities, what does that mean for us? How does it affect our perception of time and space? Each discovery in this field brings us closer to understanding the vast and complex fabric of reality. With each new advance, we find ourselves at the frontier of the known and the unknown. Quantum gravity and bubble universes are just two of the many threads that weave the vast network of the cosmos. At the end of the day, what other wonders await us in the exploration of the multiverse? Only time and scientific curiosity will tell. The nature of time in bubble universes is a topic that sparks great curiosity. Could it be that time in these universes functions differently than how we experience it in our own? To understand this, it is helpful to think of time as a flowing river. In our universe, this river follows a known course, moving linearly from the past to the future, but in a bubble universe, that course could be radically different. Consider the possibility that in a bubble universe, time is not linear. Instead of moving in a single direction, it could split into multiple streams, each leading to different events and alternative realities. This raises the intriguing question: what if time not only repeats itself but also branches out, creating distinct temporal experiences in each bubble? The perception of time may be influenced by the physical laws governing each universe. In our universe, Einstein's theory of relativity tells us that time is relative and can slow down due to gravity or speed. But in a bubble universe, where initial conditions and fundamental constants might be different, time could behave in ways we can barely imagine. Could we experience time speeding up or slowing down based on the density of matter in that universe? To illustrate this, let's take an analogy. Imagine you are at a party where the music sounds different in each room. In one room, the music is soft and slow, making time seem to pass slowly. In another, the music is fast and vibrant, making time seem to fly. Each room is a bubble universe with its own perception of time. How would this affect our lives in each of those universes? The possibility that time is different in each bubble also opens the door to profound philosophical questions. If time is not constant, what does it really mean to live in a universe? Are we destined to experience a unique temporal flow, or are we capable of navigating between different streams of time? This could change our understanding of history, memory, and identity. Moreover, quantum theory suggests that time may not be as absolute as we think. At the subatomic level, particles appear to exist in states of superposition where they could be in multiple places and times simultaneously. If this applies to bubble universes, we might be faced with the idea that time in these universes does not follow a single narrative but is filled with infinite possibilities. The implications of non-linear time in bubble universes also affect how we conceive of the future. If each bubble has its own time, does this mean there is a future for each of them? In this context, the future could be a landscape filled with bifurcated paths, each leading to a different outcome based on the decisions and circumstances of that universe. How do all these futures relate to each other? The nature of time in bubble universes may also influence life itself within those universes. If life can arise under different conditions, who would the inhabitants of those universes be? And how would they perceive their existence? It could be that in a bubble universe, life evolves in completely different ways, with a perception of time affecting its development and culture. The dialogue about time in these universes is not limited to physics. It also delves into the realm of philosophy. What does it mean to be conscious in a universe where time is not uniform? The subjective experiences of time could lead to different interpretations of reality, morality, and existence itself. This invites us to reflect on our own reality and how time as we know it affects our lives. An intriguing point is how technology and scientific advancement could allow us to explore these ideas. If we ever develop the ability to travel between bubble universes, could we experience time in ways we have never imagined? This opens a new field of exploration not only in science but also in philosophy and ethics. In conclusion, time in bubble universes is a concept that challenges our current understanding. It invites us to question not only the nature of time but also the essence of our existence. The idea that time might not be a single river but a vast ocean of possibilities is both exciting and perplexing. Are we ready to explore the depths of this idea and what it means for our understanding of the cosmos? Alternative theories to the concept of the multiverse have begun to gain ground in the world of cosmology. As scientists explore the limits of our understanding of the universe, intriguing questions arise that lead us to consider possibilities distinct from the idea of multiple bubble universes. But what implications do these theories have for our view of the cosmos? First, it is essential to understand that the idea of a single universe is not necessarily less fascinating than that of a multiverse. Some theories suggest that our universe could be the only one, or at least that models of a multiverse are not the only way to explain reality. One of these theories is that of cyclic universes, which proposes that the universe goes through an endless cycle of expansion and contraction. In this model, each cycle would be a new beginning, raising the idea that we might be in the midst of a cycle in which everything we know is just a temporary phase. Additionally, there is the theory of eternal inflation, which states that cosmic inflation did not only occur once but continues to happen in different regions of space. However, unlike the multiverse, this theory considers that each inflation could give rise to a universe, but they do not necessarily interconnect. In this sense, the idea of a single universe remains intact, but with the possibility that different bubbles of inflation exist, each with its own characteristics. Another interesting alternative is the approach of quantum gravity. This theory seeks to unify quantum mechanics and general relativity, and some of its models suggest that the universe could have an underlying structure that does not require the existence of multiple universes. Instead of thinking of separate bubbles, we might imagine a single reality that operates through different levels of complexity, where what we perceive is just one of the many manifestations of a single entity. One of the most fascinating questions that arise from these alternative theories is, what if the universe we know is not the only one, but it is the only one we can perceive? This idea suggests that, although other universes may exist, our sensory and technological limitations prevent us from detecting them. This leads us to consider the nature of knowledge and perception. How much do we really know about the reality that surrounds us? In the philosophical realm, theories that challenge the notion of a multiverse also open an interesting field of debate. If there is only one universe, what does that mean for our existence? The idea of a single universe could give a sense of uniqueness and purpose to our lives, suggesting that every action and event has a significant impact on the fabric of reality. This could lead to a deeper appreciation of our experiences and decisions. Another alternative approach is the many worlds interpretation of quantum mechanics. This interpretation suggests that each decision creates ramifications in different realities. Unlike the concept of bubble universes, there is no physical separation here. Everything occurs within a single quantum framework. Each possible outcome of a decision manifests in a parallel universe, but all coexist in a more abstract sense. This raises fascinating questions about free will and fate and how they interact in such an intricate system. When considering these theories, we cannot ignore how they impact our understanding of science. Physics is a constantly evolving field, and alternative theories remind us that knowledge is provisional. As we make more discoveries and refine our observational tools, we may approach a more complete understanding of the cosmos. Science is not just a set of answers, but a continuous process of questioning and exploration. The role of cosmology in our culture is also significant. Theories about the multiverse have captured the public's imagination, but alternatives offer an equally captivating narrative. As we explore these ideas, we begin to see science as a form of art, where each theory is a brushstroke on the vast canvas of human knowledge. This can inspire new generations to delve into the study of the universe, fueling curiosity and creativity. Alternative theories are not just an intellectual exercise, they also have practical implications. They can influence how we design experiments and what questions we ask in scientific research. As we explore the nature of the universe, we must remain open to the possibility that what we think we know could change at any moment. The history of science is full of examples of theories that were once considered truth, only to be replaced by new understandings. The interaction between science and philosophy is crucial in this dialogue. As theories develop, new questions arise that invite reflection on our existence and the place we occupy in the universe. The search for answers to these questions can lead us to explore not only the cosmos, but also our own being and the connections we share with others. Finally, when considering alternative theories to the multiverse, it is essential to remember that each perspective brings a unique value to our understanding of the cosmos, whether through the idea of a cyclic universe, quantum gravity, or the many worlds interpretation. Each theory invites us to expand our minds and open ourselves to new possibilities. Science is not just about finding answers. It is about enjoying the journey of discovery and the wonder of the unknown. In this vast universe, every question is a doorway to new realities, and every theory is a fascinating adventure to explore. The idea of bubble universes takes us to a fascinating corner of philosophy and physics. What does it really mean for other universes to exist? If each bubble is its own universe, what implications does that have for our understanding of reality? Essentially, bubble universes can change the way we think about our existence and the place we occupy in the cosmos. When we consider the possibility of multiple universes, an intriguing question arises. Are we really unique? If there is an infinite number of bubbles, each with its own physical laws and realities, then we might just be a variation of something that already exists elsewhere. This idea can be unsettling. If one universe can be so different from ours, what happens to the notion of identity and uniqueness? Philosophy also invites us to reflect on the concept of free will. In a multiverse, every choice we make could lead to a different universe. Does this mean that our decisions are less significant? The notion that in some parallel universe we could have made completely different choices can be both liberating and disconcerting. What does it mean to be responsible for our actions if those same actions can play out in 1,000 ways elsewhere? Many philosophers have debated the nature of reality and existence. If we accept the idea of bubble universes, reality becomes a much more complex landscape. Instead of a single universe governed by a set of laws, we now face infinite diversity. How does this position itself against our beliefs and religions? The existence of other universes could challenge our notions about creation, life, and destiny. The connection between science and philosophy becomes especially interesting here. Science offers us tools to explore the existence of these universes through theories and models. However, philosophy questions the meaning of these theories. For example, if we find evidence of other universes, what implications would that have for the notion of a creator or a higher power? Would our understanding of the sacred be altered? The idea of bubble universes also raises questions about the meaning of life. If there are infinite worlds, does that mean there are infinite versions of ourselves? In a bubble universe, we could exist in various forms, with different experiences and decisions. What lessons can be drawn from those alternative lives? Reflecting on our own choices and their consequences could take on new meaning. Moreover, the notion of bubble universes invites us to consider the possibility of life in other realities. If life can develop under different physical laws, then we might find forms of existence completely alien to our understanding. What kinds of beings could inhabit those universes? Would they have a consciousness similar to ours, or would they experience life in ways we could never imagine? Ethical implications also arise when thinking about bubble universes. If our actions not only affect our own universe but can also influence others, how should we act? Moral responsibility could extend beyond our everyday interactions. In this sense, every decision we make could have repercussions in a much broader cosmic fabric. Reflecting on bubble universes forces us to rethink our relationship with knowledge. Science seeks answers, but in this vast multiverse, many of those answers may be unattainable. How does this affect our quest for truth? We may never have absolute certainty about the existence of other universes, but the mere act of questioning can enrich our understanding of what it means to be human. The theory of bubble universes also calls into question our perception of time. If each bubble has its own flow of time, how does that relate to our experience of time? The philosophy of time becomes an exciting field of exploration where possibilities are nearly infinite. Could it be that time is merely an illusion, with each bubble experiencing it uniquely? In this context, the idea of bubble universes invites deep introspection. It compels us to question our most deeply held beliefs about life, existence, and the cosmos. Are we willing to accept that our reality may be just one of many? How does that change our perception of ourselves and the world around us? Ultimately, the discussion about bubble universes and their philosophical implications becomes a mirror of our deepest concerns. It challenges us to look beyond the known and embrace uncertainty. Science and philosophy, although often seen as separate disciplines, can intertwine in this exploration of the multiverse, each offering a unique perspective on the nature of reality. The final question is simple yet impactful. What does all this mean for us? How can we integrate these ideas into our daily lives, accepting that we may not be the only ones, and that our experiences could be just a part of a much larger whole, could change the way we interact with the world and with each other? Ultimately, philosophy invites us to contemplate the mystery of existence, even in a universe of bubbles. Is it possible that there are forms of life in other universes? This question may sound like science fiction, but in the context of bubble universes, it becomes a fascinating scientific dilemma. Imagine that each bubble universe is like a soap bubble in an endless sea. Each one has its own characteristics, physical laws, and potentially its own life. But what could that life be like? Physics teaches us that life as we know it depends on certain conditions: a source of energy, chemical elements like carbon, and an appropriate environment for development. However, when thinking about other universes, these conditions could vary drastically. What if the laws of physics were different in a bubble universe? Could there be forms of life that we do not understand? In some universes, the conditions might be so extreme that life as we know it would be impossible, but that does not mean there is no life. Imagine beings evolving in an environment where gravity is different or where subatomic particles have unusual properties. The diversity of life on our own planet is a testament to how surprising evolution can be under seemingly unusual conditions. Let's talk about the possibility of silicon-based life instead of carbon-based life, something that has been explored in science fiction. In a bubble universe where silicon is more abundant and stable, could a completely different form of life thrive? Perhaps their biological processes would be radically different, yet equally complex. How would they communicate? Would they have a form of consciousness? The question of life in other universes does not only refer to large and complex organisms. At a microscopic level, could there be entities that operate on principles completely different from ours? Perhaps there are beings that do not need oxygen, that feed on radiation, or that live in extreme temperature conditions. This opens up a range of astonishing possibilities. However, the existence of life in other universes poses another dilemma. If there is life, how would we detect it? The distance between bubble universes could be so immense that any form of communication or exploration becomes almost impossible. Imagine trying to send a message across an endless ocean. The likelihood of it reaching its destination is greatly reduced. In the realm of theoretical physics, some scientists have suggested that there might be indirect ways to detect other universes. For example, certain anomalies in the cosmic microwave background radiation could be traces of collisions between our universe and others. These small irregularities could provide clues about the existence of bubble universes and, therefore, their potential habitability. Moreover, life in other universes could influence our understanding of biology and chemistry. If we find forms of life that challenge our conventional notions, that could lead to a revolution in science, expanding our understanding of what it means to be alive. Biology could become an even more diverse science, with new theories about how species develop and evolve. At this point, it is important to reflect on how our search for life in other universes affects our own existence. If there are other inhabited worlds, what implications does that have for our understanding of humanity and our place in the cosmos? We might not be unique, and that could change our perception of life and the universe. On the other hand, the idea that there are other universes with life can also be frightening. If there are other conscious beings, could they be similar to us? Would they be friendly or hostile? These questions lead us to reflect on the nature of life and our own morality in a broader context. The existence of other inhabited worlds could compel us to rethink how we view our fellow beings on Earth. Theories about life in bubble universes also lead us to consider the possibility that some of these universes are completely desolate. This raises a troubling question. If life is a rare phenomenon, what does that mean for us? Loneliness in the cosmos could lead to profound reflections on existence and purpose. Finally, the exploration of life in bubble universes is not just an imaginative exercise. It is also an active field of research. Advances in astrobiology, physics, and cosmology are increasingly intertwining these ideas. As our technology and scientific understanding advance, it is possible that one day we may be able to answer these questions that, for now, seem to lie more in the realm of speculation than certainty. So at the end of the day, the possibility of life in other universes not only fascinates us but also invites us to look toward the future of our own existence. Are we alone in the universe? Perhaps, but in a multiverse full of bubbles, the answer to that question could be more complex and exciting than we ever imagined. Have you ever considered how we can explore abstract concepts like bubble universes without having to leave our own minds? Thought experiments are powerful tools that allow us to play with complex ideas that are often difficult to visualize. In the context of bubble universes, these imaginative exercises help us better understand how those parallel worlds, which some theories suggest could exist beyond our observable universe, might function. A popular thought experiment is the well-known bubble multiverse. Imagine that each bubble represents a universe with its own physical laws and initial conditions. Every time a bubble universe forms, it's like blowing a bubble in a liquid. Some bubbles merge while others separate, creating a cosmic landscape filled with different realities. What if we could jump from one bubble to another? How would our understanding of physics change if the laws in those universes were completely different? Let's consider an everyday example. Think of a soap bubble on a sunny day. From that bubble's perspective, its world is all it knows. However, if that bubble could look around, it might notice that there are other bubbles. Some larger, some smaller, some with different colors. Similarly, within the framework of bubble universes, there could be universes where the fundamental constants of physics are different. Imagine a universe where gravity is stronger or where elementary particles have different properties. What would life be like in such a place? A fascinating thought experiment is the decision game. Imagine that at a crucial moment in your life, you made a decision that led you down a specific path. But what if that decision had been different? Within the framework of the multiverse, every decision we make could have created a new bubble universe where the other option became a reality. Thus, we could imagine infinite versions of ourselves living completely different lives. What if in one of those bubbles you never learned to ride a bike, or if you had chosen a different career? The idea of bubble universes also leads us to think about the connection between reality and perception. If we consider that each universe has its own history, how could that change our understanding of truth? Is it possible that in a bubble universe, truth is subjective depending on the observer? This concept invites us to reflect on the nature of knowledge and how we acquire it. Another intriguing thought experiment is the universe transporter. Imagine there is a device that allows you to travel instantly from one bubble universe to another. What would happen if upon arrival, you realized that the laws of physics are completely different? You might discover a universe where time flows backward or where spatial dimensions are organized in a way that challenges your understanding. This kind of thinking helps us explore how theoretical physics could be much richer and more varied than what we experience in our everyday reality. As we reflect on these thought experiments, it is crucial to consider the implications they have for science and philosophy. If bubble universes are a real possibility, then our understanding of reality itself could be profoundly limited. The notion that alternate realities exist raises questions about identity, morality, and destiny. What does it mean to be you if there are infinite versions of you in other universes? How does this affect our decisions and the way we live our lives? Now let's imagine an experiment involving the echo of the bubble. Suppose each bubble has the ability to send signals to other bubbles. If one bubble experiences a significant event, like the creation of a star, it could send energy waves to neighboring bubbles. This raises an intriguing question. Could bubble universes communicate in some way? And if so, how would that affect the evolution of each universe? Thought experiments can also help us visualize the role of quantum gravity in the formation of bubble universes. Imagine that each bubble is connected through a quantum fabric that acts as a bridge between realities. What would happen if a bubble collapsed? Could it affect other bubbles in its vicinity? This exercise invites us to explore how fundamental forces might interact in a multiverse, blurring the lines between what we consider separate and unique. As we explore these experiments, it is important to remember that the goal is not to arrive at definitive answers, but to foster curiosity. Every question that arises when thinking about bubble universes opens the door to new ideas and possibilities. What does existence really mean in such a vast and complex context? How can we use our imagination to expand our understanding of the cosmos? Finally, as we conclude this journey through thought experiments related to bubble universes, it is evident that these reflections offer us a way to connect abstract concepts with our daily experience. Although we may not be able to directly observe other universes, creativity and speculation allow us to dream of what could be. In the end, the true power of thought experiments lies in their ability to inspire future generations of scientists, philosophers and dreamers to continue exploring the mysteries of the universe. The search for bubble universes is like a journey into the unknown, a journey through the limits of our understanding of the cosmos. But how is this exploration carried out? What tools and methods are being used to peek into what might lie beyond our observable universe? These questions are fundamental in the quest for answers about our existence and the place we occupy in the vast universe. First of all, astronomy plays a crucial role in this search. Telescopes are our eyes in the sky, and technological advancements have allowed these instruments to become increasingly powerful. Imagine a telescope so powerful that it can detect not only the stars and galaxies of our universe, but also the traces of other universes. This is what scientists are trying to achieve through state-of-the-art telescopes. However, despite their capabilities, there is a limit to what they can observe. The light from bubble universes, if they exist, might not be detectable due to the vastness of space and time. In addition to telescopes, there is a more abstract approach being explored: computer simulation. Scientists use mathematical models to create simulations of the universe and possible bubble universes. Can you imagine a video game where players create and destroy entire universes? That's how these simulations work. Through them, researchers can observe how bubble universes would behave under different conditions. But how accurate are these simulations compared to reality? That is a question that remains unanswered. Particle physics is also key in this search. Particle accelerators, like the Large Hadron Collider, allow scientists to study the fundamental particles that make up our universe. By colliding particles at speeds close to the speed of light, they seek evidence of phenomena that could indicate the existence of bubble universes. Could a small flash in an experiment be the key to opening the door to another dimension? Each time data is collected, a new possibility arises. There are theories suggesting that quantum fluctuations could give rise to bubble universes. These fluctuations are like bubbles of energy that arise from nothing. Researchers are working to understand how they could be created and, most importantly, how we might detect them. What if these bubbles were somehow visible? The implications would be astounding. On the other hand, some are exploring the possibility that the gravitational effects of other bubble universes could manifest in our universe. This would imply that, although we cannot see other universes directly, we might perceive their effects through anomalies in gravity. Thus, scientists are searching for patterns in the distribution of galaxies and cosmic background radiation, as if they were detectives looking for clues about the existence of other worlds. Could we be surrounded by universes that we have never been able to observe? Cosmology is also constantly evolving, and with it, theories about how these universes could be detected. International collaboration among scientists allows for the sharing of ideas and the development of new methods. Imagine a group of brilliant minds united by a single goal: to unravel the secrets of the cosmos. This collective effort is essential for advancing our understanding of what it means to be part of a multiverse. Predictions and data analysis are essential in this adventure. Scientists use statistics and models to foresee how bubble universes might behave in different scenarios. Through these analyses, hypotheses can be established that are then tested through experiments. Each finding, no matter how small, could be a step toward confirming the existence of these universes. It is important to mention that although the search for bubble universes is fascinating, it is also full of challenges. The lack of direct evidence and the abstract nature of these theories can lead some to consider them speculative. However, science advances through curiosity and exploration, and each question brings us a little closer to the truth. Education and scientific outreach are vital in this context. As more people become interested in science, more resources and support for research are generated. Collective curiosity can be a powerful engine for the exploration of the cosmos. The idea that we might not be alone in the universe, that there are other worlds waiting to be discovered, is a concept that inspires both scientists and dreamers. Finally, the search for bubble universes invites us to rethink our position in the cosmos. It offers us the opportunity to reflect on what it means to exist and how we fit into a much broader picture than we ever imagined. Each discovery, each simulation, each theory pushes us to question what we know and to open our minds to the infinite possibilities that the universe might offer us. Who knows what the future holds in this exciting quest? In the vast stage of the cosmos, cosmology is not just limited to understanding the universe we inhabit. It also invites us to think about how our understanding of the cosmos affects our culture and worldview. Cosmology, and particularly the bubble universe theory, leads us to question our existence and the place we occupy in a possible multiverse. But how do these ideas influence society? To begin with, cosmology awakens curiosity. Since ancient times, humanity has looked to the sky, wondering about the nature of stars, planets, and the universe itself. The bubble universe theory adds a layer of complexity to this quest. Let's consider how the idea that we might be just one of many universes can change our perspective. What does that mean for our identity as human beings? If there are other universes, are we less unique or, on the contrary, more special? In popular culture, concepts like the multiverse have found a prominent place. Movies, series, and books have explored the idea of alternative realities, where the decisions we make create forks in the path of our lives. These types of narratives not only entertain but also invite reflection on our choices and their repercussions. Science fiction thus becomes a powerful tool for exploring deep philosophical questions. The influence of cosmology on our culture also extends to art. Painters, musicians, and writers have found inspiration in the vast questions posed by the universe. The notion of bubble universes can inspire works that reflect the duality of existence and the connection between the individual and the collective. A painting can capture a moment in one universe, while the artist imagines other parallel worlds where history could have taken different paths. But it's not just about art and entertainment. Cosmology also impacts education and science. With the rise of bubble universe theory, new areas of research have emerged that stimulate the interest of young scientists. Universities and research centers are increasingly focused on cosmology and theoretical physics, encouraging new generations to explore questions that once seemed unattainable. Who knows how many future scientists are inspired by these theories? Cosmology also plays an important role in the dialogue between science and religion. Ideas about the existence of multiple universes can clash with traditional beliefs, leading to fascinating debates. Can science and spirituality coexist in a world where bubble universes are possible? These types of conversations are vital for the advancement of critical thinking and understanding different perspectives. In the social realm, cosmology can serve as a bridge to unite different cultures. The quest for answers about the universe transcends borders. Scientists from around the world collaborate on projects that seek to unravel the mysteries of the cosmos, showing that despite our differences, we all share the same fundamental curiosity about our place in the universe. This global collaboration can foster peace and understanding among nations. As cosmology becomes a more accessible topic, society also benefits from a greater interest in science. Educational programs, documentaries, and science communication channels have allowed complex concepts to be explained in simple and engaging ways. The bubble universe theory, although complex, has become part of the everyday language of popular science, inspiring thousands to learn more about the cosmos. Often we find ourselves at a crossroads between science and philosophy. Cosmology, by posing questions about existence and meaning, leads us to question our perception of reality. What does it mean to be human if there are infinite versions of ourselves in different universes? These concerns can be unsettling, but they are also enriching as they push us to explore our humanity in a broader context. As we reflect on these issues, we cannot forget the importance of scientific communication. With the rise of social media and platforms like YouTube, cosmology spreads beyond classrooms and laboratories. This allows the general public to engage in debates and discussions about the nature of the universe, making science part of the daily conversation. Cosmology can also serve as a tool to foster curiosity and creativity in young people. By presenting ideas like bubble universes, they are encouraged to think critically and explore their own interests. Questions about the cosmos can inspire vocations in science, engineering, philosophy, and more, thus enriching our society as a whole. However, the popularization of these ideas also brings challenges. As science becomes a common topic of conversation, it is crucial to distinguish between scientific facts and speculation. The responsibility of science communicators is to present accurate and accessible information. Ongoing education about cosmology and its theories is essential to keep the public informed and critical. Finally, cosmology, and particularly the bubble universe theory, invites us to dream. It challenges us to imagine what might lie beyond our immediate reality. This yearning to discover, to understand the unknown, is what defines us as human beings. So as we look to the stars, we are not only exploring the universe, but also the very essence of our existence. In this journey, cosmology becomes a mirror that reflects not only the cosmos, but also our place within it. The bubble universe theory has captured the imagination of many, but not everyone is convinced of its validity. Why are there criticisms of this fascinating idea? To answer that question, it is essential to understand that in science, skepticism and criticism are part of the discovery process. When a new theory is presented, especially one as revolutionary as the bubble universe theory, it is natural for questions and doubts to arise. Critics of the theory argue that the existence of bubble universes is to some extent difficult to prove. How can something be demonstrated that by its very nature may be beyond our reach? This is one of the most intriguing issues facing scientists today. Without direct evidence, some scientists feel that the idea becomes more speculation than a solid scientific theory. A common argument is that if bubble universes are truly independent, then they should not interact with our own universe. How can we be sure that we are not simply imagining this alternative reality? The lack of tangible evidence creates a void that fuels skepticism. However, it is important to remember that many scientific theories have faced similar criticism in their early stages. For example, Einstein's theory of relativity was met with skepticism before becoming a pillar of modern physics. Another point of criticism focuses on the complexity of string theory, which is fundamental to understanding bubble universes. This theory suggests that there are additional dimensions that we do not perceive. Some critics argue that by introducing such abstract and complex elements, there is a risk of losing the essence of what makes science accessible. Wouldn't it be simpler to accept a model that does not require hidden dimensions? Moreover, some believe that the notion of a multiverse, which includes bubble universes, strays from what we have traditionally understood as science. They ask, where does the possibility of falsifying a theory stand if it proposes the existence of infinite universes that we cannot observe? This is a fundamental criticism that challenges the very basis of the scientific methodology. After all, science is based on observation and verification. Nevertheless, some theorists argue that science evolves and that the lack of evidence today does not mean there is no path to validation in the future. History is full of examples where concepts initially rejected were accepted after advancements in technology and understanding. Could it be that over time, the tools we develop will allow us to explore beyond our own universe? It is also crucial to explore the philosophical implications of accepting the existence of bubble universes. If there are infinite universes, what does that mean for our notion of reality? For some, this can be unsettling. The idea that every decision could lead to an alternative universe raises questions about free will. Are we truly in control of our choices, or are we simply selecting a path among countless possibilities? The scientific community is divided regarding the utility of the bubble universe theory. Some believe that, although we cannot observe them, they may offer valuable explanations for phenomena we do not yet fully understand. Others argue that without a way to test these ideas, science risks falling into speculation. It is a constant tension between imagination and reality. Some critics also focus on the interpretation of observational data that might suggest the existence of other universes. They argue that, while there may seem to be clues, these can be explained by more conventional theories. Could it be that we are seeing what we want to see, rather than what truly exists? It is a dilemma that invites reflection and ongoing debate within the scientific community. In the face of these criticisms, there are those who defend the bubble universe theory, arguing that science progresses by accepting ideas that challenge our current understanding. They propose that instead of dismissing the theory for its lack of evidence at this moment, we should continue investigating and exploring. Isn't that precisely what makes science so exciting? The search for answers to questions we have yet to formulate. Meanwhile, research on bubble universes and the multiverse continues. The scientific community is in a race to discover more about the nature of reality. How much of what we know today will be transformed tomorrow? Criticism is a sign of an active and engaged community, and each objection can lead to greater understanding. Finally, it is essential to remember that science is not just a set of answers, but a dynamic process of questions. The bubble universe theory, with all its controversies, invites us to question and explore. In this sense, each criticism is an opportunity to deepen our understanding of the cosmos. Are we willing to continue exploring, even when the path becomes uncertain? The answer to that question may define not only our understanding of the universe, but also the future of scientific exploration. Research on bubble universes is in a fascinating phase where human curiosity and science intertwine in surprising ways. What questions do we ask when contemplating the possibility of other universes? The search for answers is like a journey without a map, filled with mysteries to uncover. Is there really something beyond our universe? And if so, how can we know? Scientists are exploring new ways to detect these bubble universes. The idea that other bubbles of space and time exist is exciting, but it also poses challenges. Current technology has advanced in ways that once seemed impossible. More powerful telescopes and innovative observation techniques are at the heart of this quest. Will we ever be able to see or measure the influence of these universes on our own cosmos? One of the most intriguing methods is through gravitational waves. These waves are like ripples in a pond produced by massive cosmic events, and their study could open the door to many answers. If we manage to detect waves coming from interactions between bubble universes, we could have direct evidence of their existence. But what would this imply for our understanding of physics? Particle physics also plays a crucial role in this search. Particle accelerators, which function as enormous laboratories of the universe, allow us to study how fundamental forces work in our own universe. But could these experiments reveal clues about the behavior of bubble universes? The creation of new particles could be a sign that we are closer to understanding what lies beyond our cosmic horizon. Meanwhile, string theory remains a fertile ground for new ideas. Some theories suggest that bubble universes could be connected through quantum bridges. These connections challenge our understanding of reality and offer a new framework for thinking about existence itself. But how can we test these ideas? As we advance in research, more questions arise. What happens if we find evidence of bubble universes? How would that change our conception of our place in the cosmos? Science not only seeks to answer these questions, but also invites us to rethink our deepest beliefs about life and existence. Astronomers, for their part, continue to explore the depths of space, searching for patterns that may suggest the existence of other universes. The analysis of cosmic background radiation, for example, could provide clues about the birth of our universe and potentially others. But what more can be learned from this radiation? Computer simulations are another powerful tool. By modeling the behavior of bubble universes, scientists can predict what might happen if they encountered one. This is like playing a video game where different scenarios can be experienced, but with the hope that one day we can observe them in reality. What surprises will this type of experimentation bring? International collaborations are proving essential for advancing this field. Scientists from various disciplines come together to share ideas and resources, creating an environment conducive to discovery. What advancements could be achieved if forces were united in this quest for knowledge? The implications of finding bubble universes are not only scientific, but also lead us to reflect on philosophical questions. What does it mean to be human in a multiverse? How is our identity redefined if there are infinite versions of ourselves in other universes? The answers to these questions could radically change our perspective on life. Meanwhile, skeptics also have their voice. They critically examine the bubble universe theory, raising doubts about its testability. These critiques are essential for maintaining scientific rigor, but they also generate an exciting debate about the future of cosmology. Can the existence of bubble universes really be considered without tangible proof? Thus, research on bubble universes stands at a turning point. Each new discovery, each new question brings us one step closer to understanding our reality, and although the road ahead may be uncertain, human curiosity drives us to keep exploring. What wonders await us in the vast ocean of the multiverse? The answers are out there, waiting to be discovered, and we are here, ready for the journey. In a world where so many questions remain unanswered, the search for bubble universes is a reminder that knowledge continues to expand, just like the universe itself. And as we continue our exploration, each small advance is a step toward the great mystery that surrounds us. Who knows? Perhaps in the not-so-distant future we will discover that we are just one bubble among many, floating in the vast cosmos. When we look at the night sky with its thousands of twinkling stars, it's hard not to feel a mix of wonder and curiosity. What lies beyond what we can see throughout this journey through the vast cosmos? We have explored fascinating concepts from string theory to cosmic inflation and delved into the intriguing idea of bubble universes. Now, it's time to pause and reflect on all that we have learned. What does all this mean for us and our understanding of the universe? The notion that we might be just one of many universes is undoubtedly a concept that challenges our perception of reality. Imagine an infinite ocean, where each wave represents a different universe with its own physical laws and realities. Isn't it exciting to think that perhaps some of those universes could have their own forms of life or even versions of ourselves? This idea becomes a kaleidoscope of possibilities that invites us to dream beyond the limits of our own world. Science, at its core, is a journey into the unknown. With each discovery, we get a little closer to unraveling the mysteries of the cosmos. However, questions also arise that seem to have no answers. What happens to information in a bubble universe? If one universe separates from ours, can information cross that barrier? These questions are not just curiosities. They push us to reconsider what we know about physics and the nature of time. Sometimes science resembles a giant puzzle where each piece is essential to complete the picture. As we explore quantum gravity and the nature of time, we begin to see how everything is interconnected. Could it be that these bubble universes are not just isolated entities, but part of a larger cosmic fabric that we are still trying to understand? Reflecting on this can change the way we perceive our existence. The philosophical implications of bubble universes are profound. If multiple realities exist, what does that mean for our identity and our choices? The understanding that we could be just one version of ourselves in a sea of possibilities raises questions about free will and destiny. Are we truly in control of our lives, or are we merely actors in a larger cosmic play? The search for other universes is not just a theoretical exercise, it is an active exploration that is underway. Scientists are tirelessly working to develop new technologies and methods that could allow us to glimpse beyond our own universe. Each advance is a step closer to understanding our place in the cosmos. What discoveries await us in the future? Human curiosity is a powerful engine, and it is this very curiosity that drives us to keep investigating. When thinking about life in other universes, fascinating questions arise. If conditions allow for life in a bubble universe, what forms might it take? Would they be similar to us or completely different? This idea leads us to consider the diversity of life and the role that physics plays in its existence. Life, as we know it, is just a part of a much larger puzzle. Alternative theories to the multiverse also offer a variety of perspectives on the creation of the universe. As we explore these ideas, it becomes evident that science is a constantly evolving field, where each theory is put to the test and revised. How does all this connect with our beliefs about existence and reality? Science and philosophy may seem like distinct disciplines, but at their core, both seek answers to the same fundamental questions. As we close this chapter of our cosmic exploration, it is important to remember that the journey never ends. Every answer we find opens new questions, and every discovery takes us further. Cosmology, like any other science, is a dynamic field that reflects our relentless quest to understand the universe. What new horizons will open in the future? The history of humanity is full of surprises, and the cosmos always has more to offer. The idea of bubble universes may seem distant, but their study helps us better understand our own universe. As we continue to explore, let's remember that every small advance can have a significant impact on our collective understanding. Science is not just a collection of facts, it is a constantly evolving narrative where each of us has a role to play. Finally, as we contemplate the vast universe around us, let's take a moment to appreciate the beauty of the unknown. Curiosity and the desire to learn are what make us human. They challenge us to go beyond our limits and question our reality. Although bubble universes may be complex and difficult to conceptualize, they serve as a reminder that the cosmos is full of mysteries waiting to be discovered. So the next time you look up at the stars, think about all the possibilities that exist beyond what you can see. What secrets do bubble universes hold? The adventure continues, and each of us is part of this cosmic story. Let's keep the curiosity and passion for discovery alive, for the universe is a vast place full of wonders, and we still have much to learn.